The Chalk Channel is back. Hey, guess what? Today is Wednesday. Tomorrow, you have a math test. If you have questions, you might want to think about texting, emailing, FaceTiming us, because tomorrow, Thursday, you have a math test on chapter 13. You also might want to go into your Envision website, Pearson, click your green tile, and look at your book. And you know how we do those red pages in class before the test? I would maybe take a look at that, because you remember, looks exactly like your test. Just the names are changed in numbers, that's it. So I would take a look at that and let me know if you're not understanding something, all right? So we are going to start the final lesson of chapter 13 with our standard and our LEQ. We are going to talk about partitioning, which we've discussed is parting out something, making equal parts, partitioning circles and rectangles into rows and columns of the same size squares, and then count them to find the total number of them. So what we're going to do is ask ourselves, how can I use repeated reasoning, repeated addition, which is a lot like our arrays, which we've been doing, to show rectangles with rows and columns and create designs with equal shares. So yesterday's lesson, you watched a LearnZillion video on how to create objects that didn't have the same shape, but still had equal parts. For example, you may have had a long rectangle with 4 squares, and then 4 squares in a short corner over here. Both had 4 squares. Both were in the same rectangle, so they were an equal share. So we're going to use that to create designs with equal shares. Today's going to be kind of fun because we get to pull out the colored pencils, my friends. Woohoo! Woo! We are going to color. All right. So we've got Sam. Sam is designing a square quilt. The quilt must have 4 colors with an equal share for the colors. So we want to look, and we talked yesterday about how many ways we can divide a square. Well, in one way, you've got this guy over here. He can design it making 4 equal blocks. This guy over here, you have 4, 4, 4, and 4. Do they all have 4 squares? Yes?
Yes.
Yeah. Does he have 4 squares?
Mm-hmm.
Yep. Does he have 4 squares?
Yep.
So it's all equal. So we can take our design and we could do 4 squares, or we can do a long and a long, or we can even do all longs. Is that equal squares? Yes, it is. So now let's go to Hamal. Hamal is painting a design. The design, get it better than me because I can't paint and you know it. The design must have 3 colors with an equal share for each color. Create 2 possible designs. So first, our directions said we need 3 colors. 1, 2, 3. What do we call it when we're dividing into 3?
Thirds.
Thirds, that's right. And we need to make them equal shares. So, remember my standard says, how can I create designs with equal shares using rows and columns? I'm gonna look at my columns, because I have how many columns?
3.
3. 1, 2, 3. So in my first column, I'm going to color 1. Then in my second column, and I have 1, 2, 3, 4 squares. In my second column, I'm going to have my 4 squares. And And then in my third column, I'm going to have my 4 squares. Does each columns go up and down. Does each column have 4 squares?
Yes.
Yes. So therefore, it would be the same as my repeated addition. Okay? Now, it says we are using 3 colors with an equal share. So I have 3 colors. Now let's take a look at my second one. Let's take a look at the second one. This is where you get to be a little artsy, a little creative. Okay? Well, I know I have 4, 8, 12 squares, correct? And it even said in our standard, okay, that I can count the total number to find them. I told you last week that we can, I don't want to hear my boys and girls going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's first grade, kindergarten. We can do repeated addition, okay? So I know that there are 12 squares in there. And I need each column, or each color, that's my C word I'm looking for, color. Each color to have how many squares?
4.
4. Because, and I'm going to use this to tell me, because this was the easiest one to divide. So I'm going to use that to jumpstart my brain and go, I need 4 squares per color. Make sense?
Mm-hmm.
So, well, I see 4 squares over here. Then, I see 4 squares underneath it. So far, do all of them have 4 squares?
Yes.
They do. I'm left with 4 more squares in my purpley bluey box. I don't know what it looks like on the camera for you guys, but okay. They both look a little bit different, don't they? The green, instead of being vertical, it's now a square. It's a tiny square. But does each box have 4 squares?
Yes.
Yes. So does Hamal have 2 possible designs with equal shares?
Yes.
Yes, he does. All right, let's try another example, okay? Let me grab my second sheet here. All right. There we go. Okay. So we're going to make 2 different designs. Each design must have 3 colors with an equal share for each color. So I'm dividing into thirds. One design should not have shares that are the same shape. So that means, if I look here, these are all the same shape, correct?
Yes.
Not the same shape, correct?
Right.
So this one says, draw shares that are not all the same shape in one of the designs. One can have the same shape and the other one's got to have 2 different variations. So let's take a look. Let's figure out how many rows let's figure out how many boxes I have, how many squares. 1, 2, 3, 4, 5, 6. And now I'm going to add 6 how many times? 1,
2, 3, 4, 5, 6.
So I'm going to add 6 times. Okay? So 6 plus 6 plus 6 plus 6 plus 6 plus 6 is 36. So now I have 36 squares that I need to put into groups of 3. So it's the same as if I have 36 of our red and yellow counters, and I'm going to make them into equal piles, okay? So let's take a look. If I do 1 here, 1 here, and 1 here. That's thirds, correct? 1, 2, 3. But did I use the rest of my shape?
No.
No. So let's try 2s. 1, 2, 3. Do I have equal shares?
Yes.
Yeah. So I'm going to color. See, this is where it gets fun, guys. You can do this at home with your fancy paper. You can make your little brother or sister a little chart. Now, do they all go the same way? Yes.
Yes.
So my second design cannot be that way, okay? So now, I know how many must be in each square. Remember, we used this to guide us into how many squares. True?
Yes.
So, we know that this is 6, and 2 6s makes
12.
12. So I need to have 12 squares in a color, because that'll make 36. 12 plus 12 plus 12, okay? So, I know that this is 12 in here, correct?
Yes.
Now, what am I left with?
24.
24. So I need 2 12s. So I'm going to divide that in half because I already know I need 3. So I need 2 more. So I am going to divide this and this. And each section should have 12. And I can double check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Check. Everyone's got the same. Then, so, in our writing, we need to be able to explain that we got our answer by dividing it into thirds and making sure we had 12 in each third. So, I made thirds. Okay. Then I made sure there were 12 equal parts in each third. And that is today's lesson, how to figure out and design something that has the same number of squares but different shapes, kind of like yesterday's lesson. Tomorrow's your math test. You need to do some iReady tonight. Maybe take a look at the math for tomorrow in your book. And you have a practice page, and then there's a visual learning if you have questions. Please let us know if you need anything. We are here for you. We love you. We'll see you tomorrow.